Yep. So building on top of Justina's presentation, let's just add one teeny thing to the whole migration is the scale. And well, the scale changes everything. I'm not sure if many of you have heard, but whoever's following big tech in Lithuania maybe heard that, well, Danske Bank is planning to migrate its whole data centers to public cloud. Many banks tried, many failed. Some stopped, say, hey, we'll wait till this mature, we'll try it later. But here we are here. So I would like to start with a survey. Has anyone here migrated anything from, I don't know, from one public cloud to another? From your workstation to the public cloud? Not that much more hands, I'm surprised. Yeah, but I guess you know that these things can be very complex, especially if you add this strict regulatory environment which, well, banks are operating in. Now, I'm not here to talk about our bank strategy or anything like that. I'm here to talk like from fellow engineer's perspective about how we're reasoning with infrastructure at Danske Bank, how we're handling this cloud migration at scale, and maybe give you an idea on how these cloud automation platforms are built. So our migration consists of 3 phases. We're doing rehost, optimization, and then modernization. I'm not going to talk much about the optimization and modernization part. So be aware of that we're not optimizing nothing from cloud, not modernizing anything. We're just literally shifting everything we have from on-prem to the public. So why we're doing this? The main goals of our migrations are these: to unlock new capabilities, because we're a bank, we're not a cloud service provider, we're not specializing in this, so we're not going to compete with AWS on feature set, so it just makes sense for us to leverage whatever's there. Another one of these goals is a bit more controversial, like reducing operating costs. Only well-optimized cloud applications end up being cheaper in public cloud. If you're not optimizing it, if not modernizing it, well, it will end up being way more expensive. But if you'd consider that you'd still need these new capabilities that AWS provides, and what you really don't want to do is to have this Frankenstein solution where you have some things on the private cloud, some on the public cloud, then you need to have some operations people to observe these 2 different systems. You need to develop features on 2 different systems, so that ends up slowing you down and becoming even more expensive. So the first thing you do when you want to migrate anything, well, you inventorize. So we looked at our capacity currently, and well, these numbers said that, well, there's no way we're going to do this manually. You can't dedicate people to go to each of our team in the bank and educate them on how to migrate, how to rebuild, how to move their application. It will take forever, not at the speed that we want to operate in. Even if you look at this storage number, it will take you forever to replicate that amount of data to AWS. So right off the bat, we knew that we need to have an automated solution. First, to understand how our applications look like on our private cloud, we have each of our applications encapsulated into a boundary called an enclave. It's basically just subnet ranges. Within it, we have microsegments, which yet more segment our network. You have an enclave, which is application ownership boundaries. You have microsegments within it. There's availability zones, depending on microsegment, and you have VMs within them. Then those applications, microsegments and servers talk with each other. We have firewall rules. We have availability zone load balancers. And then they have this thing called external endpoint. this is just a logical thing we have for defining the connectivity between the enclaves. So here, applications talk to applications, enclaves to enclaves. So we don't want to keep approving each and every firewall rule to go to security review of each connectivity that we set up in the bank. So we created this contract. So external endpoint is a contract. It says so. You can talk from this application from external zone with this application and whatever. So you have this contract set up, and then you can go on and set up your firewall rules however you please. So there's tons of these applications within the bank. To name exactly, we have 5,000 enclaves, so imagine 5,000 applications. So there's no way you're going to do it manually. Those talk with each other in very different ways. It looks like those are talking with each other, there's connectivity loops, whatever, but in a sense it doesn't matter. It's like a big organism, like your body. There's cells which are responsible for each and everything. They talk with each other, one impacts the other, so you really have to be aware of what you're moving and in what pieces. So, to execute our migration, we split it into 3 phases. We have the wave planning, where we collect all the data of all the infrastructure we have within the bank. We identify dependencies, its components, and capabilities that we need to have to migrate this type of application. Then we have this migration automation, where we utilize the cutover tool to orchestrate the migration. And then we have this landing zone, where all the applications will fall into. So let's move to this landing zone. Here I have this design diagram of this landing zone, but the key things here are the left and the right side. On the left side we have the CLZ. So this is the landing zone where we intend to land all our private cloud applications in AWS. So it has these VPCs for each of the zones, for environment, and this is the zone where application owners don't really have any access to these AWS accounts. They're using our cloud automation platform, and through it, they're going to create these components with machines, databases, load balancers, whatever. On the right side, however, we have this zone which we intend to use for modernization. We're not going to talk about it much today, but the idea is that there you'll have the complete access to the account. You can operate with AWS components yourself, and you can build the things however you please, of course, within our controls. So why we're doing this in this way? Why to move them to landing zone where they have no access to AWS? So in a sense, it's done because we don't want to reskill all the people we have in the bank. You want for them to have the same experience. They left on Friday, they came back on Monday, the application is moved to AWS, they haven't even noticed. They're using the same tools to deploy their code, the same tools to action machines and everything. So how do you get this virtual machine right now? So we have this cloud automation portal. I'll talk about it a bit later. But the idea is that you send the request there. We don't do any TSCs no more, so it's just, well, it's no longer a selling point that you're not doing any manual work, so you issue the request, then our build engine kicks in and delivers you server to our template. Users, however, never really access these machines directly. They go to CyberArk or they deploy their code through CI/CD pipeline. Because, well, it's a bank. You never reach anything directly. Everything you do, it has to be logged, it has to be recorded. And, of course, we have these patching, chef, and whatever systems to maintain these servers that we have provisioned. So, this cloud too, many people ask, what kind of vendor software you use? Well, surprise, surprise, it's Django. The whole cloud thing is, well, it's a Django REST framework with attached Celery engine. So you have to do some asynchronous work. someone issues you a request, you want a machine, you kick in a asynchronous celery job, it falls into Rabbit, Celery picks it up and then calls a bunch of infrastructure APIs. Of course, for people to build infrastructure and code, we had developed this Terraform provider, and of course we have the UI through which you can also order the machines and infrastructure that you need within the bank. So this API, well, in a sense, it's implements this Open Service Broker API protocol. I don't want to bore you much with the protocol details, but if we would look very simple at this, imagine the catalogs from electronic shops that you used to receive before Christmas. The catalog item service object is just a type of thing that you want to order. It will be a computer, a monitor, and some you do operations on them. So the logical models would be such. It's just basically 3 types, and then you have to do some polymorphisms to implement the differences on them, depending on whether it's virtual machine or it's a database or it's a load balancer or whatever. So if we look at this very pragmatically, well, what does it take to implement you another cloud support? Well, you just have to know which cloud it is, and you'll have to have some idea to identify this resource within the cloud. And then you take the same, as you want to build the same thing in different cloud, you take all the same params and you just throw it into different processing engine. You just execute different tasks. You could create a class for this, but this is just to illustrate the example. So, like this, we transformed our private cloud portal to multi-cloud portal. So the whole lift and shift, well, is just you have to support creating same things on multiple clouds. So now we have this day 2 action, so we can create the virtual machine on AWS, which is an EC2 instance. You can create a load balancer, whatever. But what about the migration? So to execute the migration, basically you have to stage everything in AWS. You have to prepare a landing zone, set up security groups, set up EC2 instances, install agents on on-prem machines, on EC2 instances, and then you kick into MGN replication, you transfer all the data, you reduce your TTLs, and basically you will just switch over to the new machines once you're done. So to execute the migration, initially we thought, well, why would do it to Cloud 2? But as we already implemented these day 2 actions and we can create the instances there, so why not just use the same workflows and to stage the setup in AWS? So we came up with 3 discrete actions on top of what we have of this provisioning, the provisioning updates and whatnot, is to duplicate, is basically to stage an instance in AWS. So if you have microsegment, you want to create a security group, so you back up your existing microsegment, you create a security group in AWS, and basically you have prepared for migration. So you're in this migrating duplication stage. Once you're done and you confirm that everything works, you do the cleanup, you remove whatever you have on-prem, and when things go sideways, you do the rollback. So then you'll have to remove whatever you create into the AWS and just restore the data that you had. So how does this look in practice? So let's take an example. So you have a free apps ecosystem, the dependency group, let's say, and you want to move app 1 and app 2 to AWS. So you're moving across the boundaries. So you have to set up all these enclave microsegment EC2 instances. You set up the connectivity, these firewall rule copies, so you issue these duplicate actions. If things go sideways, you might do this rollback, restore one side, but you still have this one part of application move to AWS. And then you reduplicate firewall rules which are crossing the boundary, because you still have to re-establish connection as application has moved and these connectivity points have changed. So once you commit to this, you basically do the cleanup and you are done with migration of the application. So connectivity works, you verify everything, and you finalize the migration. And you do this for each of these 5,000 enclaves. So going forward, our aim is basically to improve our capabilities, to add as much more different instances that we are able to migrate to AWS, because we'll basically have to re-implement each of the capability that we have on-prem, like OpenShift, MS SQL clusters, Cassandras, Rabbits, everything. So as we're maturing and process and building up capabilities, we're aimed to reach ability to migrate even the most critical systems, criticality 1 and criticality 2. So that's all that I have to share for today. Thanks for sticking with me. If you find this interesting, we're hiring, as it proved to be way more complex than we intentionally thought it will be. So yeah, but I hope Pythonistas are not afraid of challenges. So thank you.
Thanks, Romualdas. We have a question on Discord. So is OSB API open sourced? Any usage example to cater a bunch of cloud resources like EC2, SQS, and others?
Open Service Broker API is just a spec. You can find implementations in various languages. As I've seen, quite many systems integrate out of the box with it. So it basically defines what endpoints you have to have, what are the response codes and whatnot. It's not really complex, but it's very useful whenever you're provisioning some kind of services, or I don't know, it could be whatever. You could, I bet, even utilize it to provision domino spaces and whatnot. It's just a protocol and just defines an API structure.
Okay, thank you so much. Any other questions from the audience? Okay, yeah, go ahead.
What's the exact infrastructure look like? Is it in Kubernetes?
Can you please louder?
What is the exact infrastructure when you migrate it to the cloud? Is it all containerized or some of them?
Not everything is containerized. Whatever's in OpenShift, yeah, it's containerized. But for a machine perspective, we're just replicating whatever services are running there. We're stopping them, then restarting them. There could be Dockers running, there could be anything. We're trying to not look into what exactly it is, because, well, that gets very complex. We're just stopping the services and we're starting it up. So this machine can contain whatever. So we're looking at this very much operations perspective, not like a regular developer would do.
Okay, thank you. Yes, please.
What was the percentage of going astray from the documentation that you have actually planned, and what have actually been implemented?
Oh, sorry, I didn't quite hear it.
You have documented prior to migration the whole process, right?
Yeah.
How much did it go astray?
How much do they have to change our documentation? Depending. Well, the idea is to not change anything. The changes are very minimal on basically where you look for monitoring data and everything, but you very much use the same things. Like you used the Azure DevOps to deploy your code before, you still use it. You use CyberArk to connect your machine. Well, you have no idea where it is, because you just get this window where you can issue the commands and whatnot. So it's the same thing. So the documentation changes very little. It just changes more for the infrastructure people to know how to operate these instances, how to do the patching, the chefs and whatnot.
Okay, so did you hire additional people for?
Oh yeah, very much. We had these AWS consultants helping us to execute on migration. So yeah, it's quite a feat, because the scale is massive.
How big was your team in this migration process?
This Cloud 2 portal teams they're about 10 people, but we still have on our backend infrastructure people, which is, I guess, close to 100 people. So it's quite a feat.
Quite a few. Okay, any last questions? Okay, so thank you so much, Romualdas. A big applause to you.